Streaming.
Hi everybody, how you doing today on this happy Thursday, this happy, beautiful, sunny May Thursday? We are completing our trifecta of lessons today with science, and I want to go over a skill that you're going to need in science, you're going to see it in math, and you're going to see it in reading, and probably in writing. So that is how to read graphs and charts, all of that good stuff. So it's just good practice. And let's take a look. Let's share this screen so you can see where we're going here. It's a really simple assignment, won't take long, but it is always good to have this practice. Okay. Why you want to act? Why you want to act? All right. Here we go. Let's start here. Tornadoes, like the one pictured here. Can we make it bigger for you? There we go. Are very powerful storms that cause incredible destruction. Their winds may exceed 300,000 miles an hour, and they can quickly level towns and neighborhoods in just minutes. Because tornadoes can be so serious, they are closely monitored, measured, and counted. As a result, there are a lot of data on tornadoes, and one way to present these data is with graphs. Using graphs in science. Graphs are very useful tools in science. They can help you to visualize a lot of data. With a graph, you can actually see what all the numbers in a table mean. So three commonly types of graphs are bar graphs, circle graphs, and line graphs. And each type of graph is suitable for showing a different type of data. If you were with me in the past writing class, we did look at a graph. We looked at a bar graph. So here we go. The table below shows the average number of tornadoes per year for the 10 cities that have the most tornadoes. The data were averaged over the time period 1950 to 2007. So let's always, when we look at a graph, read the title. We're looking at the average number of tornadoes per year during the time period 1950 to 2007 in cities with the greatest number of tornadoes. And we have the rank. So we'll be looking at the first, at the least to the most, because I'm going backwards. We're looking at the most to the least because we have the rank. Then we have the city in this second column. And then we have the average number of tornadoes per 1,000 square miles. So these are things when you get to the test that you're going to be asked questions about. And so bar graphs are especially useful for comparing values for different things, such as the average numbers of tornadoes for different cities. Therefore, a bar graph is a good choice for displaying the data in the table above. The table below is showing it one way that the data could be presented. So let's take a look. If I were to ask you which city ranks fifth and what is their average number of tornadoes, well, we would go from 1 to 5. We'd find Tulsa, Oklahoma, and they average 2 tornadoes every 1,000 square miles. Which city has the least? Well, we know that this is being ranked from 1 to 10, so we're going to go right to Lubbock, Texas. Lubbock, Texas with 1.6 tornadoes average per 1,000 miles. We're going to round about 2 tornadoes. Let's look at it this way. Average number of tornadoes per city, same amount of cities, and you can easily see that Clearwater, Florida has about 4 times as many as the other cities. So what do the two axes represent? The x-axis, we're talking about math here, where this horizontal line represents the cities. The y-axis, this vertical line, represents the average number of tornadoes. So again, if you were to look at Clearwater, Florida, you're looking at a little under 7.5 per thousand, remember? And what about, again, if we look at Lubbock, Texas? Well, here's the 2 line for the number of tornadoes. It's not quite 2, right? A little over 1.5. And I think the number was 1.6. So you can see it represented that way as well on a bar graph. Again, this is not being nice. It's me and the mouse. And the mouse is starting to cause me some real problems. Circle graphs. In the date table below, we're going to see the percent of all tornadoes by tornado strength for the years 1986 to 1995. In this table, tornadoes are rated on a scale called the F scale or the Fujita scale. And so on this scale, F0 tornadoes are the weakest and F5 tornadoes are the strongest. So let's look and interpret what we have here. 55% of all tornadoes are in the F0 or the mildest category. 37%, I'm rounding, are in the F1 category, the second in degree of strength. 10% are in the F2, 2.6 or a little under 3% are at F3. Then we have category 4 tornadoes, 0.7%, less than 1%, and then even less with category F5 or the strongest tornadoes. So most tornadoes tend to be in that F0 range. Tornado's a tornado, however. If we were to show this as percents or fractions, we would use a circle graph, okay? And so that's going to show the percents of F0 to F5 out of all tornadoes. And therefore, a circle is a good graph for a good choice for the data in the table. The circle graph below shows the data. Again, we can really see pretty easily that F0 tornadoes are 55%. We know looking at this circle that it's more than half, right? And then we can tell which one is second in occurrence, third, fourth, fifth, with 1%. 1%. What if the table above on tornado strength listed the number of tornadoes rather than the percent of tornadoes? Can a circle graph be used to show that? The answer is no. A circle graph can only be used to show percents of fractions or fractions of a whole. However, the numbers could be used to calculate percents, which are then showed on the graph where you're adding them up. Let's take a look at the line graph. This is showing the number of tornadoes in the United States per month, averaged over the years 2009 to 2011. That's the title of our graph. If you notice in this column, we have the months during tornado season, January through September, and then we have the average number of tornadoes. Oh, I'm sorry, we do have the whole year. It's just cut off. Let's put that a little more in focus. There we go. So, which can we see kind of a peak period, a peak season for tornadoes? It looks like spring, right? April, May, June. When do we see the least tornadoes? We see them in January. And then it kind of fires up. And then you can see it diminishing. So if we want to look at changes over time or trends in data, such as how the average of number of tornadoes vary throughout the year, we would put them on a line graph, which is really what I was talking about, our peak tornado period, right? Between April and June and then we start to fall off. Boom, 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 boom. But you can see the peak tornado period quite easily when looking at this line graph. So, question, what's the trend in tornado numbers by month throughout the course of a year? The answer is that the number in tornadoes rises very rapidly from a low in January to a peak in April, and then it kind of slowly declines the rest of the year. So here's our summary. That graphs are very useful tools in science because they display data visually. And the most commonly used graphs are bar graphs, circle graphs, and line graphs. Each type of graph is suitable for a different type of data. Bar graphs are suitable for comparing the values of different things, like the average number of tornadoes for different cities. Circle graphs are used to show percents of a whole, such as the percent of all tornadoes with different strengths. And line graphs are really useful for showing changes over time, such as the variation of tornadoes throughout the months of the year. And review, what's the advantage of showing data in a graph rather just listing it in a table? Well, you can see, you're able to see the data more clearly. They point to exactly where your attention should be. And a circle graph shows what? Percent of a whole. And then let's finally take a look at this data in this table right here. So we are looking at the average numbers of tornadoes a year in selected states. These few states and the average number of tornadoes. So what kind of graph would we use? Are we going to use a circle graph? No, we're not talking about percents. We're going to use a line graph. Doesn't really show change over the same. You're looking at different states. So I probably would show a bar graph. So what I want you to do next, is there's a next, is take a look at this graphing practice quiz. You've all been assigned. It's in CK12, and there are says it takes about 10 minutes to complete. And let's take a look at the preview. You'll need to get 10 correct answers to complete your practice goal. Let's preview it together. So basically what you're doing here is reading the graph. And based on the graph showing temperature and time, and you're looking at what is going on with temperature over time, because you see the minutes are increasing, all right? So based on the graph of the temperature of a chemical reaction over time, what is the temperature at 2 minutes? So find my unit of time in minutes. Here's 2, okay? And my temperature is about right here. So what is my temperature? We're gonna estimate, right? It looks, would we say 0? Looking on this graph, do we see them coming together at 0? Do we see them coming together at 30, which would be somewhere around here? Or do we see the 2 points coming together, if you were to draw between here, I can't do it, between here and here? What is this line right here? Looks like it's closest to 0, right? Check it out. There we go. So the rest is for you. Hit a sister up if you have a problem. I can't read minds that well, so you got to let me know, okay? That's all we are doing for today. I will see you tomorrow for reading and social studies and math. So everyone, enjoy this beautiful day. Even if you're able to get out there for 10 minutes, let that be your dessert for the day. So take care, and I will see you tomorrow.